All right, PF1 video 8. Seems like we should have had a lab by now, but yeah, it's this point still just lab 1's the last one we had, and that was, what, a week ago, something like that. But good news, I guess, if you've been aching for a little more homework, we're going to introduce lab 2 today and get that assigned to give you something to work on then over the next few days. This isn't going to be too tough, but and we'll give you several sample problems to kind of lead up to that. And you know, it's again kind of like your math classes, where the instructor will show you how to do this, that, and the other, then assign some homework problems that are very similar. Of course, in math class, the very first ones are identical, other than perhaps the numbers are different, you know. But eventually, the goal then is to be able to take the various skills that you've practiced and to kind of be able to put them together to solve problems that are a little different and maybe kind of merging multiple things into one problem. So, and that's kind of what we're going to do today. We're going to give you 4 or 5 different sample programs, and then we'll assign lab 2, where you're going to kind of take and pick and choose things that we showed you in various examples and put them together to solve a slightly new problem. Again, it's just a twist over something we've done already. And it's going to involve a little bit of calculations and so on, but we're going to go ahead, just since it's been a bit since we've assigned you a lab, and introduce lab 2 today. And we're certainly going to use some operators, but to be clear, we're also going to continue our in-depth, if you will, dive of a number of different things about the Java programming language. We'll come back to operators and cover them in greater detail then in our next lesson. But anyway, for today, let's see, I probably have some house cleaning to do here. All right, and we do vid everything and lab everything. That looks pretty good. So let's just jump in here with video 8. But what we're going to do, though, and this is not too uncommon, is if we want our program to read data from the user, so the description that we would use, we would say that we want our program to be interactive. We want the program to interact with a person in this case. And well, to do that, you have to remember that import statement, and your buffered reader declaration is kind of clunky, you know. Then also have to remember to put a throws IO exception on the main method header. So there's a number of things that you have to do to write an interactive program, and I wouldn't expect you guys to be able to do that off the top of your head just yet. So what we might do instead is just copy our lab 1 to our current directory, give it a new name, and then we might use that as our starting point, that it already has the class header and the method header and all the rest of that, and our buffered reader declaration and the import statement and so on. And we're going to kind of go to town to work on that to get it to serve the purpose that we need. But I think it'll be easier than starting from scratch. You guys can execute the exact same command. Now what I'm going to do, I'm in my home directory. You can be in your whatever notes, samples, whatever, you know, directory underneath PF1. But I'm going to copy. And again, this is kind of a variation of a full path, and that will allow it to work no matter where you are in your file system or in your little directory tree. So I'm going to copy from my home directory /PF1, uppercase on that, of course, /lab1, lowercase, /lab1.java space. Now, if I just hit a dot, you guys know the drill on this. If I hit a dot for the destination, it would copy that file to my current directory. But then I'd have to rename it. But that's pretty cool. We could copy and rename at the same time. So I'm going to specify a new name for the destination. All right, so and the name's going to be vid8.java. All right, so it copied my lab 1 from where it should be, same place as where yours should be then, to my current directory, wherever that is. And then it's going to rename lab1.java to vid8.java. We have asked this question before. Will this compile at this point? No, because that's right. Lab1.java is going to have a class header that says class lab1, and the class name and the file name have to agree. So, what the heck? Just to do so, I guess. Let's go ahead and edit this, and we'll cat and compile and run. Make sure we have a good starting point. Then we're going to go in and slash and burn. So vi vid8.java. And I'm going to go to my class header here first and change that to vid8. And just to get my command history set up, I'm going to go ahead and cat vid8.java, javac vid8.java, and java vid8. And I'm immediately going to do a Control-C and abort here. But anyway, I've got my command history set up. So it did compile and run. And so now we're going to go in and we're going to get rid of an awful lot of it, but again, it's still a good starting point because it gives us everything we need for our buffered reader. So back up into our command history go, and I'm going to edit this thing. All right, so let's get rid of these comments. All right, so a DD and then a dot, dot, dot to continue deleting lines. That looks pretty good. And I'm going to get rid of this comment here also and declare our variables. We do need our buffered reader. And, well, our input string, oh, what the heck. I'm just going to go ahead and slash and burn on all these variable declarations also. We're not going to deal with grades and counts and sums and averages. And also our input string variable, we're going to do something different. I don't need these comments or this initialization. And in fact, I don't even need a loop. I don't need a loop. And we'll get rid of this comment. I'm going to fix my indentation here in just a bit. But let's see. This is not too bad. We'll get rid of the grade equals line and everything that follows that inside the loop. There's just not going to be a whole lot left. In fact, we'll just do this. So look how little this program is. Then I'm going to come here and just do a 4x to delete 4 spaces, then a dot to repeat it. So I'll take a breather here, let you guys kind of catch up. And this is not quite what we need, but it's pretty good. As it is, it's not going to compile or run due to, well, we're making an assignment to a variable that I have removed its declaration and so on. But, you know, note, the main thing I was going for here, I got my import statement. And the worst part of this probably is our buffered reader declaration. That's a bit for you guys to remember off the top of your head right now. And oh yeah, the other thing is our throws IO exception, which is necessary for any interactive program that we write. So this is pretty good shape. So we're prompting the user, and we're going to change that prompt, and we're reading something in. So all right, so we're going to just practice working with strings a little bit here. So I'm going to go below my buffered reader declaration and declare another variable. How about string? Don't forget capital S on string. And I'm going to say fname. All right. And, thinking ahead, what the heck, how about lname and full name? So I bet you can guess what fname and lname, those are first name and last name. So we could have spelled those out, but I got lazy there, I guess. But anyway, since I already had one F name, I needed to make this different. So what the heck, I just wrote it out as full name. So we're going to prompt the user for their first name and their last name and do a couple things with it then. This will be a pretty simple little program. All right. So what I want to do now, oops, upboard, let's see here. There we go. So what I want to do now is come down here and change my prompt. How about enter your first name? A colon and a space after that. You know, do note and remember to get this space in here at the end of our prompt string. Otherwise, the cursor will be right up against the colon. And anyway, what we're used to having a little bit of a gap there. If a computer is asking us a question, it'll ask the question, give us a little bit of room there, and then we type in our answer to the right of that. And do note we have a print instead of a print line, so it will leave the cursor sitting right there, right after this colon space at the end of our prompt string. And then it's going to read in, so br.readline, we're going to take a minute to talk about this in greater detail here. So notice that we're calling a method called readline. Now to get to that method, we have to use this variable called br. What the heck is a br? Oh, up here. Br was declared to be, this is a variable declaration statement right here. We're declaring variable br, and you know what the syntax for a variable declaration statement is. You specify a type and then the variable name. And you remember the drill. Then if you want, you can specify an equal sign and then give it an initial value. This is a lot uglier than what we've seen before in the past. But anyway, all of this is a variable declaration statement where we're also initializing the variable that was declared. Anyway, the variable that was declared was BR. Now we're dealing with classes and objects and so on here, and we're going to cover those in detail after the midterm, so don't worry too much about it right now. But just do, trust me and recognize that here we're declaring BR to be a variable. The data type is buffered reader. And we're also initializing it, in kind of a convoluted way here, but anyway, we're initializing that variable BR also. And then we use that variable BR to get to this method called readline. We're going to be talking more about methods as we go along, especially, again, after the midterm. But it's all right. So, one other little change we'll make here, and I think we're about ready to let this compile and run. It's not going to do much just yet, but input string is a variable we had in Lab 1. How about we change that? Well, we're asking them to type in their first name. How about we then capture what is returned from this readline method with our variable fname? All right, fname, there we go. So I did a change word command on that. And oh, what the heck, we can go ahead and print out the first name then also, just so we get some other meaningful output out of our program. So we'll follow it up with a system.out.println. All right, fname is equal to, and then plus fname as such. Looks pretty good. All right, Bruce. All right, you guys. I think that looks good. You guys can holler at me if you see any syntax errors in there and a little bit of code that actually typed in. I think we're in pretty good shape. I'm going to go ahead and save it. I'll cat real quick in case you're still typing away, still plinking away there. See if it'll compile for me. It did. All right. So not a very exciting program, but again, we're just taking a little more time to cover these things in detail. So let's go ahead and run her then. So we will. All right. So I ran the program, and of course, you know, it executes these lines of code one at a time from top down, starting at main. So we declare our buffered reader variable, we declare our string variables, then we get to our print statement and we prompt the user. And see where my cursor is? And it kind of looks pretty good there. I prompt the user, enter your first name with a colon and a space, and my cursor is sitting right there. And then I go down and I execute this line of code here. And well, it's funny, we're not quite done executing this line of code. We're inside this method called readline. So we're executing this code inside this readline method. And what it is doing is it's waiting for the slowpoke user to plink away on the keyboard and type in their darn name and hit enter. And then when that happens, then we will wake up inside of readline, and the name that was entered in as a string is going to get returned and assigned to our variable fname. See, this is an assignment statement. This is an assignment statement. You remember the syntax on an assignment statement. This is our assignment operator, the equal sign. To the left of it, we have a variable, in this case, a string variable. And then remember, we gave you the syntax in your notes. In fact, speaking of that, I need to get to here eventually, so we'll just pull those up just for grins. All right, PF1 and our notes. And we'll skip down to the bottom then, or towards the bottom, variable declarations and assignment statements and all the rest of that. Hey, here we go. So an assignment statement, to the left of our assignment operator, we have a variable. And then on the right-hand side, we can have a constant or a variable or an expression. Well, I'm going to say, we could put another or on the end of here, but an expression, some calculation that takes place, we have to execute some code in order to get there. I'm going to say that when you're calling a method, which is what we're doing right here, it's kind of sort of an alternative for an expression. We're executing some code here that will eventually return a string. And then that string is being assigned across the equal sign to our string variable, which should work just fine. But anyway, so that's what our program is still doing. Our program is running down here. Of course, I say it's running. It is a process, and it's on the run queue, but it's currently blocked. It's asleep. It's asleep, so it's not twiddling its thumbs and burning up CPU time or anything, to make the system efficient. While it's waiting for the slowpoke user to get around and finally typing in their name, the program actually goes to sleep. But it will be woken up when we finally type in our name, for instance. So I'll just type in, how about Bob? All right. So once again, our program still is inside that readline method until I hit enter. So if I backspace this off and type something else in, perfectly fine, kind of like when you're composing a command line with bash and so on. But anyway, I'll go ahead and hit enter. When I do so, all right, our program is going to wake up. What was typed in by the user will be returned from this readline method, assigned to my variable fname, and we're off to the races. And the next statement, of course, is just our print statement, and it's going to print out what was typed in, ta-da, which is Bob in this case. So let's talk a little bit about this. This is going to lead into our discussion that we're going to talk about today, and then a little bit more then in our next lesson. So this print statement here, we're printing out, now note that this here that's highlighted, that is a string literal or a string constant. It is a string, but it doesn't vary. It is always fname equals, some spaces sprinkled in there then also. And then this over here is a string variable. Well, what the heck is this plus sign in between? What is it doing? Well, that's an operator of sorts. We can give you that in our notes. All right, let's just do that real quick. We're going to have something in our notes. So let's see. This is going to be video 8. And we're going to cover operators in greater detail in our next lesson. But what the heck, since it kind of popped up here on its own, it's just good as time as any to talk about that operator. So all right, note that the, if you will, the plus sign has been overloaded in Java. In other words, it has more than one function, if you will. All right, what are the rules for that? All right. If, let's see, one or both of its operands, all right, so think about operators. So in algebra class, you're used to addition, subtraction, multiplication, division. Those are operators, and they have operands. Those are what are being added together or subtracted or multiplied or whatever. Same thing here. This is an expression, back over to our code. This is an expression of sorts. Now, if you just kind of squinted your eyes and you saw this plus sign here, you might think that's the addition operator. Well, yeah, you might think that, but I don't know how you're going to add two strings together. So back to our notes. If one or both of its operands are strings, then it is the, quote, string concatenation operator. All right. String, what's that word? Concatenation. Have we talked about concatenation? Have we mentioned that term this semester? We have, if you remember when we introduced the cat command. The cat command, and I told you my guess, I've never bothered to try to look that up, but my guess is the cat command has nothing to do with a kitty cat, a feline animal. Instead, cat is probably short for catenate, which is short for concatenate. And we mentioned that concatenation means that you take two strings and you append them together. All right. Anyway, that's what we're doing here. Back to our code. Hey, we've got this plus sign in our program. So, Java has to figure this out. The compiler has to figure this out here. It sees this plus sign in our code, so it has to recognize, are we doing addition there, or is this string concatenation? And, well, our rule says, you just see it down here below, if one or both of the operands are strings. Well, what is this? A string literal. What is this? A string variable. So in this case, both of the operands are strings. So this plus sign isn't doing arithmetic addition, it's doing string concatenation. So we're going to take this string literal and this string variable, stick them together, and then the result is what gets printed. So we take the result, the concatenation of this string literal and their string variable, and we pass it, a single string, to the print line method to be displayed for us then. All right. So anyway, so there's that string concatenation. Well, so we have this if one or both of the operands are strings. Well, what if neither of them are strings? We'll cover that next then, so that's the obvious then. All right, if neither, or we could just say else, but anyway, if neither of the operands are strings, then it is the addition operator. The arithmetic, we'll even say arithmetic addition operator. Hey, there you go. So that's the one that we would expect, of course, in algebra class. That darn plus sign was always the arithmetic addition operator. And it often is in Java, but not always. It might be the string concatenation operator. So anyway, we've also introduced this other term, overloaded. That kind of means you've given it a second function, a second job to do, depending on the context. All right, so there's that. Okay, so back to our code we go. Hey, we understand a little bit more about buffered reader and how that works and so on. So we've allowed the user to enter their first name and read that in. Let's go in now, and we're just going to add a bit to that. Let's go ahead and have the program then prompt the user to enter their last name. So this should be a little simple and copy and paste kind of a thing here. Copy and paste is wonderful. It works great. I use it all the time, but you have to be careful. Guaranteed I will plenty of times this semester. Oops, copy and paste, and then forget to make some critical little change in the paste version of what you copied and end up with a little logic error, but we'll try to be careful here. All right, so what I want to do now is prompt the user to enter their last name and then read it in. and then print it out. So, all right, so we're going to have a bit of a change to make to all of these lines of code. And again, I could, if I highlight this, then it is part of my Windows clipboard, and then I could go into insert mode and then right mouse click, or you can just do it all within VI, if you remember there. So, to do it all within VI, you can just count lines. So let's see, I want to copy this line. That's 1, 2, 3, 4. And to get the blank line up above too, I'm going to say that's line 5. So 5, YY. We see down at the bottom, 5 lines have been yanked into our delete buffer. Go down here, P for paste. All right. So now we're ready to change these last few lines to where they're dealing with the last name. So we'll arrow over, do a CW command, change first to last. And then don't forget here with our variable, change it to L name. I'm going to use an R on that. Just type an R followed by an L, and you're done. And then once you've done that, you can come over here to the next F and hit a dot, and it replaces it with an L. Come over here to the third F, and then hit a dot, and it replaces it with an L. So anyway, hey, there we go. So now we're going to prompt the user to enter their last name, and we'll print it out. So I did do some copying and pasting, which is wonderful, but at the same time, kind of risky, I guess. I think I did that correct and didn't forget to make any critical changes. Let's see here. So we'll save that in case you're still plinking away there. We will cat and compile and run. All right, so the old program is stuck there in our first read line statement. I'll type Bob. As soon as I hit enter, then we're going to wake up inside of this read line. The value that was typed in by the user will be returned, assigned a variable F name. We'll print it out, and then we're going to give the second prompt. There we are. Once again, we're asleep inside of the read line method, waiting for the user to type something in. How about Smith? When I hit enter here, and then Smith is going to be returned, assigned to my variable L name, and we'll print it out. Hey, looks pretty good. All right. And just for the heck of it then, to give you one last practice, again, we had 2 places already where we're dealing with string concatenation. Again, right here, what gets passed to print line is a single string. It is the concatenation of this string literal and this variable. Oh, same thing down here. What gets passed to print line is the concatenation of this string literal and this string variable. But let's just do one more. Explicit string concatenation. Let's go back in with a VI down to the bottom. With capital G, we'll zap you down to the bottom. And then how about full name is equal to F name plus L name. Oh, there we go. So, of course, logically, that makes sense. We're going to concatenate the first name and the last name together to create their full name. And we'll print it out. No, what the heck, we can be lazy here. And we'll steal this print statement, paste it down below, and, well, we need to change L name to full name. I'll just, once again, maybe put my cursor there at the beginning, CW, and then type in full name, hit escape, arrow over to L name, and hit a dot to repeat that edit. Looks pretty good. All right. I think we're done. So just a little bit of review on working with strings here and introducing string concatenation a little more formally. Solving simple little problem. Reading in 2 names, appending them together with concatenation. Let's see if that bugger's going to compile. All right. And run. All right. Oh, that's right. How about Bob and Smith? And yeah, this looks kind of good. But generally, if I have to write my full name, I do what? I put a space in between those 2. So it concatenated them together. What I typed in here was 3 letters, B-O-B, and 5 letters down here, and it concatenated them together. But yeah, it'd be nice if we had a space in between. So we'll fix that real quick, and we'll wrap this example up then. So we're going to come down here, and when we append them together, let's append a space string literal in the middle of this. So now my string expression, this is, of course we have numeric expressions, and so on. This is a string expression. I have 2 operators. And well, to be clear, just like in mathematics, remember operator precedence, multiplication and division, then addition and subtraction, and so on. But what if you have, several things that are well added together in math class? Good news is with addition, the order doesn't matter thanks to the commutative property. But anyway, so how is that executed, though? You know, when you're wanting to study that in greater detail, how would a computer add A plus B plus C? It doesn't add them all at the same time. It's going to, oh yeah, same operator precedence. We've got add in that expression twice. In mathematics, it's going to, and in computing, it's going to evaluate those from left to right. So yeah, so to be clear, this little expression here will be evaluated first. We're going to take the first name and append a space to the end of it. And then we'll get whatever that first name was, in this case here, Bob, with a space at the end of it. And then we're going to take what's highlighted there, that results, that expression there results in that string, Bob, space. And then we're going to use that as the first operand in another expression with the operator plus and then the last name, so the last name will get appended to the end of Bob space to give us the Bob space Smith. I think that should work for us. Let's try that out with a cat and a compile and run. All right, we'll go with the same old standby here, Bob and Smith. And thanks to the space here in the middle, when we concatenate these together, a little more complicated expression. Ah, there we go. When we print it out, that looks a little more natural than with that space in between. Piece of cake. All right. And anyway, we've given you an example using string concatenation here. We are going to use string concatenation again as a critical part of Lab 5, which is a ways down the road. In fact, that is immediately after the midterm exam. But anyway, we won't do a lot with string concatenation until then, but I wanted to cover that. Let's go ahead and do another example that's kind of similar. And this next one will not be interactive, so we'll start it from scratch. So let's see here. Let's jump in with vi vid8b.java. You guys know the drill. Public class vid8b with an open and a closed curly brace. Then I'm going to hit escape and capital O to go in insert mode on the line above the curly brace. How about you guys remember this maybe by now? Public static void main string args inside of parentheses there. As such, okay, looks pretty good. All right. So we're going to practice working with strings here again on this example also. Okie dokie, let's see here. So how about string, and I'll do a halfway decent job of giving us a good variable name here, I guess. So we'll call this S1. Oh, I think we'll save a line of code in S2. And I could have initialized them then, but oh, just for the heck of it, I'm going to initialize them separately here. So about S1 gets assigned a string version of 5. And S2 gets assigned a string version of 6. All right, as such, you know, we mentioned before, now we're just kind of demonstrating that. We mentioned that, yeah, you can store integers or floating point numbers or booleans or characters inside of strings. And anyway, sure enough, S1 and S2 are declared to be strings. And I'm storing the integer number 5 as a string inside of S1. Same thing with S2. And then I'm going to come down, oh, let's tell you what we'll do here. And we'll just add on to our variable declarations. How about we'll add in another one called, oh, well, it'll start with an S. I like that. Sum. All right. How about sum is equal to S1 plus S2? And then we'll print out sum. Gosh, this is going to be just one effort here to do the whole thing, I think. System.out.println. And you guys know the drill here. We'll print sum is equal to plus sum. You know, to be clear, you know, we recognize that, you know, this is going to return a string, and just a string is going to get printed out. I'm going to put this back in just a second. But, you know, to be clear, to print a variable, you could just do that. You could just say print line and then the variable. And just whatever the value of the variable is gets printed, but there's no descriptive information that's printed along with it, so you can tell what the heck you're looking at. Imagine a program that has 25 variables, and you print this one, you print that one, you print the other one, and you know, you're printing all these different variables, and you get all these different numbers that you're looking at, but you don't know which variable is which when you're looking at the output. All right, so a good habit in programming in general, and we're going to say you must do so in your labs and so on, is we're not just going to print a variable just by slapping it into a print statement like this without also adding a descriptive little string literal. It tells us what the heck it is that we're looking at. What's the name of the variable that is being printed? Now, for a trivially simple little program, not necessary, but, you know, trust me on this. You're not going to get paid to write trivially simple little programs, and they will be more complicated with many variables involved, and to help you and others figure out what the heck is going on when you're developing or testing or whatever this code, we want to print out, what is this variable that's being printed? Hey, this little string literal does that for us. So I think this should, all right, cat vid8b.java, I think this should compile and run. All right, let's see here. I catted it for good luck, so hopefully that'll fix us up. Java C vid8b.java. Don't forget your B on these things here then. Hey, it compiles. And then we're going to run it. And anyway, so trick question. What should be displayed when I print out the sum? Look closely where we're calculating, quote, calculating the sum. Ruben's nodding. Oh, yes, he's not going to be deceived by this tricky program here. So, you know, I have this variable called sum, and, well, we got a 5 and a 6 are used to initialize variables S1 and S2. So we're calculating the sum of 5 and 6. Of course, the obvious answer would be 11. I think some students might have already hit enter at this point, and they saw something else. So, yeah, this is an integer that we squeezed into a string, and this is an integer we squeezed into a string. But our little rule that we just typed just a few minutes ago, oh yeah, if one or the other or both of the operands are strings, this is not the addition operator. It is the string concatenation operator, okay? So we don't take the 5 and the 6 and add them together. We take the 5 and the 6 and we concatenate them together. And in the world of strings, 5 plus 6 is equal to what? Anybody? 56. Ding, ding. Good job, Ruben. All right. Oh, yeah. Okay. So, in this case, this was a string variable. It was declared to be a string right here. And this is a string. As a result, this is not the addition operator. It's string concatenation. It says you just simply cram them together to create a larger string, if you will. Anyway, so there you go. So yeah, if we wanted to do addition, and we mentioned this that when we were just talking about the different data types that we had. Hey, strings are great. You can store anything in a string. Yeah, but I said you can't do arithmetic on integers or floating point numbers or whatever that are stored in a string. Here we've demonstrated that. We tried to, quote, add them together, but what we got instead was just we concatenated them together. And anyway, that's not the sum I was looking for here. So how to fix that? Well, that'll be our next example then. So this didn't quite work. Well, it proved how Java works, and just another example of string concatenation. But it also demonstrated a shortcoming of storing numbers, whether they're integers or floating point or whatever, inside of strings. Yeah, you can put them in there, but you can't do number kind of things with them then. All right. So we're going to take off with another one. And all right, once again, this one will not be interactive. So let's just start from scratch. How about vi vid8c.java? All right, so we'll just, oops, and once I accidentally hit the old backslash there, so it's waiting on the next line, but I could hit Control-C to abort or just finish the line up with an enter. Hey, there we go. How about public class vid8c with an open and a close, escape, capital O to go in insert mode on the line above. Public static void main string args. As such. Okay. So we're going to do something similar to last time. Gosh, we could have copied it over, but oh, what the heck, this will be okay. How about we just say string S1. And oh, what the heck, we'll just even do this just for grins, just to show you that you can. You guys remember the rules on a variable declaration statement. If you want, you can throw in an equal sign and an initial value, which we've done. All right, and then if you want, you can declare another variable, S2, and we'll initialize it also as equal to as such, and that's that. Okay, that is that. And now I'm going to change things up here a bit, and for my variable sum, I'm going to make it an int. I'm going to make it an int. Now, we can't add S1 and S2 and get the result that we want. We can add integers, however. So, yeah, so actually backspacing up here a bit, I'm going to also declare I1 and I2. So I've got two strings, and I got three ints. So what I'm going to do here is I'm going to convert S1 into an int that has the appropriate value that is represented in this dadgum string up here. And I'm going to convert S2 into an int, you know, with the appropriate value based on what was used to initialize the string S2. So we'll show you how to do that then. And this was lurking inside of your lab one that you typed in, so I might have, you know, just casually mentioned it, but we're covering it in greater detail then. So this example is going to show you how to use the parseInt method, which is inside the class called integer. All right, so what we're going to do here, I'm going to make an assignment to I1 is equal to integer, that's the name of a class, integer. Note the capital I, you know, we remember our identifier naming rules. Class names should start with a capital letter, and as it turns out, integer actually is the name of a class. And then a dot, you know, and we've seen that before, system dot out dot println, for instance, you know. But anyways, integer dot parse, P-A-R-S-E, and then int, capital I-N-T, and I'm passing in S1. Okay. So integer.parseInt, oh, just to do so, hey, what the heck, I've highlighted it here, so I'm going to leave it highlighted and pull up my notes real quick, just to put it in the notes, so when you're scanning your notes and trying to figure out, where did we cover that in a little bit of greater detail? Oh, we'll just come over here, all right, and a control V, there's integer.parseInt. All right, and we'll say string S, okay. We'll convert string S to an integer, actually to an int. All right, so integer.parseInt. Whatever you pass in needs to be a string, so in this case we're passing in a string value, which I'll just make up variable S here in this case. We'll convert that string to an integer. All right, so back we go over here then. So what I'm passing in this case is a string variable, not called S, but in this particular case it's called S1, so that is a string. It has the string double quote 5 double quote, and parseInt has been written for us, and that's a method that resides inside this class called integer, and what it can do is it can convert a string that you pass in to an int. So in other words, when we return from parseInt, all of this that's highlighted here then gets replaced with the return value, and the return value is going to be the int equivalent of this string up here. In other words, it's going to return the integer quantity 5, and get it, and we'll assign that to I1. And just to prove that, what the heck, we'll take this step at a time. How about we print out I1? System, oops, need an extra space in there. System.out.println. All right, I1 is equal to, and then plus I1. Oh, you know, just to do so, we got plenty of time for the examples we need to work today. So here, what gets passed to the println method, let's look at, okay, we've got a plus sign here. To the right of the plus line, I have I1, which is an int. Okay, that's good. Looking like this might be an arithmetic addition operation here. Uh-oh, well, no. This is a string to the left-hand side. The left-hand operand is a string. So even though this is a string, anyway, even though this is an int, I guess I should say, since this is a string, once again, according to our rules we covered earlier, this is the string concatenation operator. So what happens here is Java will, the terms that is normally used, it will promote this integer to a string. In other words, it will create a string variable that has the string equivalent of int variable I1. And then that string equivalent of I1 will get appended to this thing here, and then the concatenation gets passed to println and gets displayed. So anyway, it will print out the value of integer variable I1 is the short version of all of that. Well, cat, excuse me, this is 8C. I need to redo my command line history. Cat vid8c.java. That's an easy way to mess up, is to forget to update your command history here. And then Java C vid8c.java. All right, Java vid8c. All right, so there we go. So to be clear, you know, all we did was print out the value of variable I1, but the good news is I1 is an int, and I can do int kind of things with it then. So that worked perfectly fine. We need to also convert S2 into an int and then assign it to I2. We'll do that with a copy and paste of this line of code here. And we could print them both out, would be fine. Oh, what the heck, we'll do that, I guess. So back and we go to VI. Oops, all right, back we go into VI. Get rid of the backslash on the end of it there. And I'm going to take, what the heck, I'll group those two lines of code together. And then let's steal them. 2YY and P for paste. Change that. Oops, change this to a 2. Change S2, or excuse me, S1 to S2. S2, there we go. I'll get this right. And then down below, change this to a 2 in 2 different places. So make sure you, so you should have no I1s or S1s, and everything is now I2s and S2s in these 2 lines of code down here. And that will convert the string 6 into an int and print it out. So hey, we're looking good here. We'll verify that real quick with our incremental development, we call that. How about a cat and a compile? All right, and a run. Looking pretty good. So now finally we're ready to calculate the actual sum. All right, so we will go jump back in, jump down below. Now sum is equal to I1 plus I2. You know, if we go back in history here, I probably could just scroll up and show you. Hey, look at right here. Sum equals S1 plus S2, and then we print out the sum. We're doing the exact same thing, except for an oops now. This is an int. This is an int. So now this is arithmetic addition, so we're in good shape there. Let's steal a print line above, and we will paste it down below and change this to sum. So very similar to the previous example, but, well, you know, recognizing that since S1 and S2 were strings, well, we had to convert those into ints before we could add them together then. But now our addition is going to work like we would expect. We will cat and compile. All right, and run. Looks pretty good. All right. Questions on that? Tell you what, kind of like in our last lesson, we had kind of a shorter day than normal. We're going to have the same thing here today. So even though we've only been at it about 45 minutes, I think we're probably about halfway through. So why don't we take a 5-minute break here then. We'll come back, pick up, go through another couple of examples, and introduce Lab 2 and send you guys off to it then. Let's take a few minutes. Okay, we're back from our break, and we had a question during the break. And, you know, one of the more pain in the neck kind of compiler errors that you might get is if you're missing a curly brace. Because a lot of times the curly braces, their mate is some distance away from them in the code. You can imagine your class header is at the very top, and then it ends at the very bottom, for instance. And the method header is not much different from that. So let's go back into VI here. And I'm going to zap that curly brace there. And then when I try to compile, hey, well, cat for good luck. We're really going to need some good luck here for it to compile when we're missing a curly brace. So I reached the end of the file and didn't find the mate of, let's see, so we got rid of a close, so we have an open without a mate. And I think I might have mentioned, but I'm not sure, but it's very, very handy here. Check this out. If I go back into VI, and notice if I put my cursor on a parentheses, all right, on a parentheses, and I type Shift 5. In other words, I'm typing the % key. In VI, the % key knows the rules that compilers use to match up parentheses and square brackets and curly braces and so on. So every time I hit the % key, it shows me the mate of the one that's currently under the cursor. If I move my cursor to a square bracket, then the % key, you know, will toggle back to its mate and so on. If I move the cursor down here and hit the % key, it's showing me the mate for the curly brace that marks the beginning and end of my main method. But when I put my cursor up here and I hit the % key, it doesn't have a mate. All right, couldn't find it, so it doesn't move the cursor anywhere. And again, the good news is Bill Joy and whoever followed him up then when they wrote the VI text editor, they added that very handy command that knows the same rules that the compilers use to match up curly braces. You know, once again, it's not how they're lined up vertically. Remember, we took one of our programs before, we turned the whole thing into one big line of code. If you remember that, one line of text contained the whole program. The indentation and the nesting and so on is just for our human eyeballs here. But anyway, there's rules that go beyond that and how compilers match up curly braces. And VI knows how to do it too, and it can't find the mate for this bugger. Did they help you find your error then?
I had two open curly braces.
Oh, there you go. Yeah, that's an easy thing to do. You know, it looks pretty reasonable to, you know, for instance, come down here. I'll put the missing one in, you know, like as such. But, it, you know, it doesn't really look bad to have this. You know, that kind of has a decent look to it, doesn't it? You know, that looks perfectly fine, you know, in terms of indentation and everything else. But, you know, based on the way they're pointing, if you will, this isn't open, this isn't open. These here are also open. So that's such an easy thing to do. Man, it sure is. So we'll do R and then a closed curly brace. Come up over here, do the same thing. Let's see if that bugger's going to compile for us real quick. It did. So there you go. So yeah, don't forget that little percent. That could be your good friend there to help you find those errors. All right. So we got just a couple of other examples then. So the next one is once again going to be interactive. Interactive. And it's going to be kind of similar. So our last cat here real quick just to see where we're at again. Oh, yes. So the last program added, if you will, S1 and S2. It calculated the sum of the ints that were stored inside of these strings. And we had to jump through some hoops to make that happen, but you know, we learned how to do so and we made it work. So let's do the same thing now, but let's add two integers that are entered interactively and calculate their sum, okay? So we're gonna write an interactive program that's gonna, again, kind of combine little bits and pieces of our first program with our third program, if you will. So we can copy lab 1. What we might do instead is just copy vid8.java. So let's copy vid8.java. That was based on lab 1. It was interactive. Remember, it just appended your first name and your last name together. And now I'm going to call it, got to get this straight, vid8d.java. All right. So I want the interactive part. So as a result, I want the buffered reader and the throws IO exception and the import statement and so on. And we're going to use that as our starting point. And it's kind of closer. It's got more stuff cleaned up out of it than starting over with lab 1. But okay, so now we're going to, oh yeah, oops, excuse me, Control C here, VI vid8d.java. First thing I'm going to do is slap a D on the end of the class name. And again, I like to make sure that my starting point will compile and run before I start to doctor it up. And again, it gives you the added advantage of get that command history fixed up. So how about cat vid8d.java, Java C vid8d.java, and Java vid8d. And it's going to prompt me for first name, last name, abort, abort with a Control C. There we go. All right, so let's jump in here, and we're going to do something kind of like we did before, but we're going to prompt the user not for their first name and their last name. We're going to prompt them for your first integer and your second integer. But they're going to get read in as strings. Okay. So let's go to work on this bugger here. All right. Well, one thing is I'm done with first name, last name, and full name. So I'm getting rid of those variables. Now, actually what I might do is just zap F name, L name, and full name. But I'm going to leave string as a data type here and kind of thinking ahead and also kind of flashing back, you know, reminiscent here. Let me pull up lab 1 real quick just for grins. All right. So here and here. PF1, lab 1, and clicking on it here. So you remember that lab 1, we had a variable called input string. And, you know, it's kind of a descriptive variable. String, since it's in the darn variable name, then you would expect input string to be, a string. And this is the variable that's going to store the input that was entered by the user interactively. So what the heck, just as a kind of a flashback to lab 1, I might go ahead and use the input string variable again here then. So I'm going to do that very thing. Input underscore string, so there's that. All right. So what I'm going to do, enter your first integer. We'll just say number. All right, enter your first number as such. And it's going to read it in. Okay, now the thing is, you know, we would get compiler errors galore here because I got rid of F name and L name and full name and so on. But we're going to kind of work our way down. So we know what readline is going to do. It's going to stop our program and wait for the user to type something in. When they do so, then it's going to return whatever they typed as a string and assign it to the variable on the left. Uh-oh, we got a problem. The variable on the left doesn't exist anymore. I just got rid of it. So we need to store what comes back from readline in a string variable. Hey, I've got this other string variable here, just like lab 1. When we come back from readline, then we're going to store the result in our variable input string. All right, so we're going to do the exact same thing here. Get rid of F name and replace that with, all right, replace it with input string. And oh, what the heck, we'll just go ahead and print out input string. So I'm going to come over here, do a CW, input underscore string, hit escape, arrow over here to F name and hit a dot, and there you go. And you know what I'm going to do here? What the heck? I'm going to go ahead and delete what's left. And we'll just get this working and kind of go from here. So let's just read it in, print it out, just make sure we have what, you know, something that will work as our starting point. Build up our command history and so on. I don't think we've done that yet. I don't think. So I'm going to cat vid8d.java, java c vid8d.java. All right, java vid8d. Enter your first number. Oh, what the heck, 5. Printed it out as a string. As a string. Okay, so far so good. And now let's go back in. All right, back into VI we go. And, oh, what the heck, we can leave the print statement in there, I guess. You know, oh, you know what we ought to do instead is, let me think of this. Yeah, we'll leave that there for now at least. We'll probably come back and change it in just a bit. But that's kind of okay. All right, and then I'm going to come down below. In fact, oh, what the heck, we'll just be lazy here. And I'm going to steal 1, 2, 3, including the blank line above, 4 lines of code. So how about a 4, YY, arrow down, P for paste. Enter your second number. Okay, so we're going to read it in and print it out. And note, now this is something that's different from our version, our program number 1, where we had F name and L name. In fact, let's just do this real quick. Cat vid8.java. Notice here, I prompted the user once, read something in, and printed it out, but I stored the result in variable F name. I did the exact same thing again, but I stored the result in L name. 2 different string variables are storing what comes back from readline. Here, on the other hand, when I vi vid8d.java, I'm assigning what comes back from readline to the exact same variable, input string in both cases. Is that a problem? It certainly could be, but there's a key difference between this problem and the next one, which will become clear here in just a bit. So this is going to prompt the user, read it in, and then print it out. We're still all in the world of strings. I haven't converted anything to an int. I don't even have any int variables here in the mix so far. So I certainly am not going to be able to add these things together yet, but we're getting there. Let's go ahead and make sure it will work with our 2 strings being read in. We'll just kind of plug away at this. So how about a cat? That's not the one. Oh, we can just stick a D there. There's cat. And a compile. There that bugger is. And a run vid8d. First number, 5. Second number, 6. All right, so far so good. So it's reading them in, printing them out. And now I want to calculate their sum. So back in we go. All right, back into VI. So what we're going to do here then, after we've read in the first number, I'm going to, I could declare the variable here. Oh, what the heck, I'll go up top here. Int I1, I2, and sum. And then down here, I'm going to say I1 is equal to, you guys know the drill now. This is similar to what we did last time. Capital I, integer dot parse int. Open parentheses, input string. Very similar to lab 1. Very similar to lab 1. We'll take a peek at it real quick. Oh, yes, right. Here we go. We read in something from the user, stored input string, we pass input string to parse int, and then we assign that to an int variable. It was called grade then, now it's called I1. So still very similar to lab 1. And hey, now that I have I1 initialized, instead of printing out input string, let's put our cursor at the beginning of input string, do a CW, I1 escape, arrow over and hit a dot to repeat that. Oh, now we're going to print it out as an int instead of as a string. And then come down here and all right, tell you what, we'll just copy and paste our integer.parseInt line, do a YY there, and then down here in a P for paste and change that to a 2. And I need to change my print statements also then. So I'll just take my time, come down over here, put my cursor at the beginning of input string, CW, I2, escape, arrow over and a dot. So I think I'm kind of done here with this round of changes. Okay, the typing has slowed. Now, I want to again refer to something I just mentioned a minute ago, so I'm just going to scroll up here real quick. And note, here we prompted the user, read in their name and stored it in variable fname. And then we prompted the user, we read it in and stored it as lname, 2 different string variables. Could we have just used the same variable both times? Well, no. If we used like input string here, and then we used input string here, guess what? The first name got clobbered, right? Think about that. If this was input string, well, we would have read in the first name, stored it in the variable called input string, and printed it out. But then when we reassigned input string, now the first name is lost. It's gone. It got clobbered. We overwrote that variable, and we couldn't concatenate the first name and the last name because the first name was gone. On the other hand, down here I use the same variable both times. But I think it's okay. Why is it okay? I use the same string variable to capture what came back from readline here and here. The reason it was okay was, well, I just needed to store the string version of what the user typed in just for a brief instant in time so that I could then pass that string to parseInt so that I could initialize variable I1. Once I've initialized I1, I'm kind of done with input string. I1 was just used to temporarily capture the string that was typed in by the user, and then once I convert that string to an int, I'm golden. I don't need that string anymore because what I'm wanting to do eventually is add these strings together, so I needed the user's input stored in an integer, and I've got that here, I1. I do the same thing down below. I do use input string again very briefly just to capture what comes back from readline, and then I pass that to parseInt, and then the second integer is stored in variable I2. So note, I do have I1 and I2, and those are 2 different int variables, so that I can calculate their sum. Kind of like here, I needed 2 different string variables, so I can calculate the concatenation, if you will. All right? So that's kind of a logic question on why it is okay to reuse variable input string. We just used it to get us from one line of code to the next in converting the user input to an int, and then we're done with input string. And clobbering it again the next time makes perfect sense instead of declaring a separate string variable when there's no real need for it. So now we're going to print out I1 and I2, and we're going to be ready then finally to calculate their sum, and we'll be done then. So let's see here. We'll cat for good luck. Cat vid8d I think is correct. We'll compile vid8d and run. Now when we're printing these things out, they're going to print as ints. They do print out correctly. I think finally we're ready to calculate their sum and print out the sum. So let's do that real quick. Back in we go. Down to the bottom. Sum is equal to I1 plus I2. And then I'll be lazy and steal a print statement, paste it down below, and change I2 in this case to sum with my CW command. I think we're about done. All right. Okay. All right, the typing has slowed in case you're still plinking away there. We'll cat real quick. And compile. And run. All right, well, we'll try with a couple of numbers. Hey, that sum looks correct. We'll try with a couple of other numbers. All right, yes, that looks correct. I'll assume that it is. Looks like it's working just fine. All right, questions on that? Okay. We have one more example, then we'll introduce Lab 2 and talk about it and so on. And send you guys packing that early today. What I should have done, let me do this real quick. VI vid8.java, just for the heck of it. I'm going to get rid of this blank line and this blank line. And tell you what, let's do here. I'm going to log in a second time. And just once again, just since we have time to do so, just compare those two. vid8 and vid8d. So let me log in over here also. Okay. So we'll just cat vid8.java. And then over here, cat vid8d.java. Anyway, these programs, I just changed the spacing just a tiny bit, but they're pretty darn similar now. You know, over here with strings, dealing with first name and last name, we prompt the user, we read it in, we print it out, and then eventually down here we, you know, and sometimes you can be kind of sloppy and say, hey, we calculated the sum of these two strings. You know, we just appended them together. It's kind of the equivalent of calculating the sum. We used our addition operator. That's probably why sometimes they'll go ahead and call it sum. But that worked perfectly fine. Now over here, when we wanted to deal with, calculate the actual sum, well, we needed some integer variables involved in the mix. And since readline, it returns a string. It doesn't return an int. Now there's some alternatives to readline, to be clear. There's something called a class called scanner, which you can use also. If you all have heard of it, that's, you know, that's good. But to be clear, on our labs, we're going to use buffered readers. And anyway, our buffered reader, it returns a string. And if you need to input a double or an int or something else like that, there's going to be some conversion that takes place. Just like right here, we had to convert the string variable to an int using our call to parse int. But anyway, notice the similarities here. Prompt the user, read it in. Yep, here we had to convert. So that's the extra line of code in this little block of code. All right, same thing down here. Prompt the user, read it in, convert, and then print it out. And then down here at the end, hey, whether we're calculating the concatenation of the strings or the sum, those two programs are very, very similar, but with some notable differences. And again, one key thing here, if we had used the same variable here and here, then when we concatenated them together, we'd be taking L, you know, for instance, whatever, F name plus F name, and we lost one or the other of the names. You know, we lost the first one. If we reuse the same variable here, it would reassign that F name variable, and the previous F name would be lost. So we had to use two different variables. But over here, input string, we could use the same one both times because we're just using it to capture what comes back from read line. And then the very next line, we pass it to parse it, and we're kind of done with it for a little bit then. Questions on vid8d? All right. One more example, then we'll open up permissions on the lab and talk about it. We'll go and log out here then. Okay. So, oh yes. So this could be another one, start from scratch, that will not be interactive, so we'll just type it in from scratch. VI vid8e.java. Blank class vid8e with an open and a close. Public static void main string args. As such. Okay. So let's do some little real world calculations here. I'm going to say int r is equal to 3. Kind of like in math class, r might be a good variable to store the radius of a circle. So we're going to do some excuse me, calculations that will calculate, for instance, the surface area of a circle. We think about the formula for the surface area of a circle. What is that formula? Pi r squared. That's what we're looking for, Michaela. That's very good. So, oh yeah, so as soon as we throw in pi, we can't, Unfortunately, we can't solve this problem completely in the world of integers because 3.1415, you know, so if we typecast pi 3.1415926, if we typecast that to an int so we can stay in the happy world of integers where I like to work, well, then we'd get an approximation, of course, because pi would be reduced to just the number 3. So we'll need a reasonably accurate version of pi. It'll need to be stored in a double. It will need to be stored in a double. So, oh, what the heck? Well, where do we want to do that? We'll do that. Oh, that's fine right here. So how about double pi is equal to, all right, 3.141592654. That's how many digits I have pi memorized to. What is that, 7 or 8? And that's not much. Have I mentioned this? For some reason, it seems like I just mentioned this the other day, but I think it might have been to my other class. On memorizing digits of pi, this literally is how many digits I have memorized, whatever that is, 7 or 8 digits. So, hey, that's pretty good. I don't know if y'all had memorized more or less than that. And the goofy thing is, this funny thing is you get older and you look back on, why do I do this, or why do people do this, or whatever, and it's like, well, that's just what we've always done. It seems to be the answer to a lot of questions. And when I was your age, and taking calculus classes and all the rest, pre-cal and calculus. Didn't have calculators, but we didn't have graphing calculators back then. We had what we called scientific calculators. You know, in the drawer where you kept your phone book in the kitchen at home, you might have had just a little 4-function calculator to calculate the sum and difference and products and quotients and so on. You know, back in the day. But for if you're taking a math class, well, you want to throw in the trig functions and exponentiation and some other more advanced features and so on. And so anyway, back in the day, we had what we called scientific calculators, and they had really everything that your graphing calculators do, except they didn't graph. All right, they didn't have the graph capabilities, but they're still reasonably powerful little calculators. And of the many buttons that they had, more specialized, they had a button where you could pull up pi. And on that calculator, all those years ago when I was in high school, this was the pi that my calculator spit out when I used it. And that's what I have memorized back then and still have memorized all these years later. And I don't know one digit more. That's it. All right? So I don't think I'm a contender for the bragging rights on having memorized digits of pi. And for grins, just since we have time to do so, I'm going to do a quick Google. World record number of digits of pi memorized and recited and verified correct. Now you don't have to type all of that. Just how about world record number of digits of pi memorized? I guess I hadn't mentioned it to you guys before. Someone would know the number because it's pretty astounding, and you won't be able to forget this number once you see it. Nobody find it yet? Oh my, there you go. Can you believe it? Someone sat down and memorized 70,000 digits of pi. Oh my God, yeah, there you go. Thanks for that, Gabe. And they sat in front of a little committee of people that sat there with a checklist, and checked it off as they went. 10 hours to recite that. I cannot imagine. I certainly don't have the memory capability, nor if I did, the desire of memorizing 70,000 digits of pi. And wouldn't that be weird? 10 hours worth guaranteed. You're blabbing along here for an hour or two or whatever. Bathroom break, lunch breaks. You're going to need to take breaks. Okay, well, we're going to leave off right here, and then you got to come back, check your notes or whatever, and continue on. I cannot imagine. It also kind of makes you wonder, was there any favorite part? As they were reciting, oh, this is my favorite part of pi right here. This little sequence is just beautiful, I don't know. It seems kind of stupid, but anyway. So, in case you were wondering, no, I'm not a contender. I've got 69,992 digits still to learn, I guess. But so there's that. But amazing that someone could do that. Okay, so there's that, and where we headed all. Oh yeah, one other little thing. Let's just play around with pi just for the heck of it. Check this out. System print line, and I'm just going to say pi is equal to. Now I have this uppercase, and we'll understand why in just a second. So then plus, and then pi. So this is kind of okay. This is all right. So we'll just verify this. Not much of a program. We'll get our command history set up though. Vid8e.java, Java C vid8e.java. and Java vid8e. All right, that looks pretty good. You know, and just again, just to show you that, yeah, you know, some tricks that we learned before. If you wanted to, you know, as soon as you slap a typecast in here, for instance, int, so we're just going to stick it in the print statement itself here then. So now the compiler is going to treat pi as if it was an int, and we're going to not even bother to use it in the calculation or assign it to a variable or whatever. All we're going to do is, oh yeah, append it to this string literal here and print it out. And we'll see what happens now as a result of the typecast, just for the heck of it. Cat compile and run. Oh, there you go. Hey, that's my version of pi right there, you know, just perfect. But probably not very good. But why is it uppercase? Well, we'll show you here right now, I guess. So what we're going to do, eventually we're going to do some calculations with pi. In fact, let's just throw this in. And let's come down here and, oh, I'll just stick it down below. Double, and we'll say area. Okay. And then I'm going to come down here and I'm going to say area is equal to pi multiplied by, and oh yes, now you might remember that I have used the old BC program. In the BC program we did things such as this, and the up arrow in BC and in some programming languages the up arrow is the exponentiation operator. In BC, yes, and in some programming languages, but not Java. All right, so, but this is one thing that's kind of aggravating. All right, so R, oops, this will compile and run. And boy, does that look like R squared based on, you know, our practice banging away on the BC program. That looks like R squared. It's not. It's a bitwise operator for exclusive OR. I don't expect that to mean much to you, but it is an operator, but it's not exponentiation in Java. As a result, this is not going to give you R squared. It's going to give you a wrong answer, okay? So put something in your notes. Don't use the up arrow as exponentiation. To be clear, there's a class called math that has the ability to raise a base to a power. It's the EXPR, I think it is the name of that method. But, oh yes, R squared, of course, is just shorthand for what? R squared is shorthand for R times R. Very good. So we'll just use that, okay? So there's that. And, oh, what the heck. Now let's come down and we'll print them out. Oh, I'm going to be lazy still, this print statement here. Come down here. How about area? Then come over here. Change that to area. All right, as such. I still got my print statement for pi in there, just for the heck of it, I guess. We'll come back to that in just a second here. But I have a radius of 3, and I know what pi is, and then I'm going to take and multiply pi times 3 times 3. Now, one big important thing, you guys want to learn pro tips and so on here, is, you know, you young programmers, you're used to the results that come back from a computer. You trust that they are going to be correct, because they often are. But when the computer program that you're running was written by a clueless newbie, perhaps such as yourself, you might not trust the results that come back from that particular program, and you want to verify whether it's working correctly. And one thing to do is, instead of just running the program and looking at the results and, yeah, I guess that looks reasonable, you know, because of course your nature, we're all trusting and perhaps a little lazy. I know I am, and I'd be very likely to say, yeah, I guess that's good. But if you'll do the following instead, and when you can, try to estimate what should the answer to this expression be before you run the program. And then you run the program to see if the result that it spits out, you know, lines up with your guesstimate, if you will. So pi times R times R. Well, pi is a little more than 3 times 3 times 3, so it's a little more than 3 times 9. It should be a little more than 27. Maybe around 28, 29, something like that is our reasonable guess. And then we'll run the program and then see if what it spits out matches what we guesstimated it would be. So we will cat and compile and run. Eventually, here we go. Hey, there we go. So we guesstimated 28, 29, something like that. Sure enough, that looks good. Okay, back to the question of, Why do I have pi as uppercase? We're gonna work our way to that here then right now. So back in we go. We might neaten this up a little bit. Let's see here. No, actually this looks not bad. We'll tell you what I'll do instead. I'm just gonna declare R up at the top. I'm gonna declare it, but not bother to initialize it. Then I'm gonna come down here and I'm gonna say R is equal to 3. Okay. Oh, what the heck? We'll put spaces around to be consistent with the other. So I declared it at the top. I use it in this little calculation. I print it out. That looks good. That looks perfectly fine. And then I'm going to come up here and I'm going to steal 4 lines of code with a 4YY, P for paste, and I'm going to change this to a 4. So I'm doing the same calculation with a different radius. All right. And hey, just for grins, before we compile and run this, approximately what is the area of a circle with radius 4? Well, 4 times 4 is 16. 16 times 3 is 48. But we have to add in a little bit more because of the 0.1. So I don't know, 49 or 50 or something like that, somewhere in that range. So let's see if that's going to work. So we will cat and compile and run. All right. So it looks like we're looking pretty good. And oh, just for grins, let's do one more. Let's do one more for a radius of 5. So I'm going to take these 4 lines, Y, Y, P for paste, change this to a 5. 5 times 5 is 25, times 3 is 75, so I don't know, 77 or something like that might be a reasonable guesstimate then. So we will cat and compile and run. All right, looks pretty good. Looks pretty good. So back in we go. Let's talk about pi a little more. So imagine that we're so good here at doing area of circle calculations that we decide to set up a web page, and we are the internet's go-to place for anybody that needs the area of a circle calculated for a given radius. All right, they come to our web page, we will calculate that for them, and there you go. And imagine that there's kind of a long program that did various calculations using pi. Well, we want this variable here. Think about this. Variable pi, it's a variable, but we don't want that variable's value to vary. Pi is what it is, and we don't want it to be reassigned. We don't want it to be reassigned. Now, I still have this one print statement here. I'm going to leave it there. I'm going to get rid of the typecast because I want it to print out exactly what was assigned here, which is going to be the 3.1415926. We'll just verify that real quick here with a quick cat. Compile. Oops, I might have overshot there. Compile. And run. Yeah, so 3 point, just exactly what we typed in. That's what gets printed out. That all looks just fine. But imagine if, because I literally do remember this. Oh, we could just do it down here just for grins. I'm going to pull up a calculator. All right. So I do remember when I was in, 9th, 10th grade, something like that, taking Algebra 1 back in the day. And I remember my math teacher telling the class that you could, when desired, as an alternative to pi, you could replace it with 22/7. 22/7. Now, of course, I don't have my drawing tablet pulled. Oh, I've got everything here to do so. So just for the heck of it, let's pull it up again. We've got time. So 22/7. Now, literally, it is no lie that I definitely remember good old Miss Springer. I remember Miss Springer telling us that as an equivalent to pi, you could use 22/7. Now, I'm maybe misquoting her a little bit. I'm sure that she said it was an approximation. It was an approximation. Because, of course, if we take, all right, that looks good, 22, and we divide it by 7. 7 goes into 22 3 times. Hey, we're looking pretty good. 3 times 7 is 21. We subtract and we get 1. And anyway, we can kind of continue to work our way across. But is this going to continue forever? This is 3 plus 1/7, and 1/7 isn't like 1/3 that continues on, forever and ever and ever when you convert it to a decimal. I'm not going to bother to go through all of the long division here. It's looking pretty good so far, but, all right, let's go and just divide that with our calculator. Over here we go. 22 divided by 7. Oh, I said that. Oh, look at that. Gosh, I didn't remember that it was as close as it was, but that actually is a pretty good approximation. 3.14. 3.14. So it actually is a pretty darn good approximation. You know, it's obviously a little more than 3. But that 1/7 gives us all of this over here. So it's good to, 2 decimal points. That's not great, but it's a pretty good approximation. But anyway, imagine if me or one of my classmates back in the day remembered our math teacher, in my case, good old Miss Springer, telling us 22/7 is an alternative to pi, but we didn't remember she said it's an approximation. And so I'm hired on with the surface area of a circle calculator, company, and I'm working along here just fine. But for the heck of it, I reassign pi. Pi is equal to, now to be clear, if I did this, 22 divided by 7. So I notice that this version appears only accurate to whatever that is, 8 or 9 digits. And 22/7, according to that calculation I just looked at with the calculator, that looks like it's even more digits. So maybe this is more accurate. Maybe I didn't look into it too closely. And I'm going to come up here and steal this print statement. Y, and P for paste. And so I'm thinking this is going to be, I wish I'd left it here just for the heck of it. I'll pull it back up. Calc. 22 divided by 7. So, problem number 1, I think that, this certainly has more than 7 or 8 digits. I don't know what that is, 12 or 15 digits, something like that. So I'm thinking, I just glance at it and think, yes, that's an improvement. That is an improvement. So I'm going to use that. But to be clear, have I assigned this number here, 3.142857, yada, yada, yada? Is that what I've assigned to pi? I wouldn't necessarily expect you guys to know until we talk about this in our next lesson. But look at this here. When you think about calculating the sum or the product or the difference or the quotient of integers versus floating point numbers and so on, there's some rules that govern how that works. And again, we're talking about it again in the next lesson. But when you add 2 integers, the sum that it returns is an int. If you add 2 floating point numbers, the sum that it gets calculated and returned to you is a floating point value. Okay? So it looks at the data type of what you're adding or subtracting or multiplying, dividing, and it does the calculation and returns the answer as the same data type, which makes sense. 22 is an int. 7 is an int. The result that gets returned from that expression is an int. And in the world of integers, my young friends, what is the quotient 22 divided by 7? And the answer you need to give me must be an int. So I'll ask that question again. In the world of integers, which is where we're in when we're calculating this quotient, because the dividend is a quotient, the dividend is an int, the divisor is an int, so the quotient is going to be an int. So I'll ask that question now. In the world of integers, what is 22 divided by 7? 3. So this was not going to be as accurate as we want. But it's sure as heck, if you do integer division, then it's definitely not going to be very accurate. So the reassigning of pi 22/7, not good. So let's look here. So we will cat and compile and run. Hey! So when you have a radius of 5, pi r squared is exactly 75. How'd that end up being the case? Oh, because pi is now 3.0. Now this is kind of interesting. The compiler didn't give me an error here. I assigned a double variable an int quotient. Anyway, it will allow you to do that. I mean, just think about that. If you have a number that doesn't have anything to the right of a decimal point, well, it's okay then to go ahead and put it into a number that does allow for digits to the right of the decimal point. It's just that you don't need the to the right of the decimal point part. So we're not losing any precision when we assign an int to a double. But let me ask you the reverse question. Could we lose some critical information if we assign a floating point constant to an int? Absolutely. Floating point constant can have stuff to the right of the decimal point. To squeeze that into an int, you're going to lose everything to the right of the decimal point. So if you tried to do that in reverse, if you said I is equal to 3.1415 or whatever, it's not even going to allow it to compile. Because the compiler's going to say, whoa, 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 you might be losing some precision here, assigning this floating point constant or expression or variable or whatever. The compiler's going to say, you're going to lose some precision. It'll give you a compiler error. And you'd have to get around the compiler, you'd have to tell the compiler, trust me, I know what I'm doing with a typecast. But anyway, so that would be necessary if we're going from a double to an int. But when you're going from an int to a double, okay, that's fine. You don't need what's to the right of the decimal, but it's there if you need it, but you don't, but everything's fine. So it did allow this to compile and run, but we got the wrong result. Okay, how to fix it, how to improve upon it? Well, let me put this back. Somehow I zapped that.
I have a question.
Question, yes, Michaela, thank you.
So when you assigned pi to be like the exact digit, it ran those two area calculations under it, and then it reassigned.
Oh yeah, excellent question. Very, very good. Yeah, you know, once again, you know, our program, now if you have loops and so on, it can change, you know, that we can repeat code and so on. I don't have any loops, I don't have any if statements, just a sequence of statements here. And that's exactly right, Michaela, that we assign pi this pretty accurate version, accurate to whatever it is, 8 or 9 decimal points, that's right. And then we use pi, this value of pi, here, and get a pretty accurate area. And then we use that same version of pi here and get a pretty accurate area. And then dumb newbie programmer here remembers their 10th grade math class or whatever it was, and they reassign pi 22/7. And even worse, they calculate the quotient as an integer, and now we have a horribly inaccurate version of pi. But that only affects us for this last calculation because it just affects the code that follows the clobbering of the good value of pi for a less accurate version of pi. That's right. So, we could improve upon it a bit. Again, this result is 3. And we saw that here and here. We can improve upon that a little bit, a couple of different ways. Just think about this. Go down to the bottom because it's close to the bottom. This looked at the dividend was an int. The divisor was an int. It calculated the quotient and returned it as an int. And to be clear, when you do int division, it truncates. It doesn't round. So in the world of integers, 99 100ths, 99 out of 100. That's not a bad, score for you guys to earn on a lab or a test or something else like that. 99 out of 100. That's 99%, right? But in the world of integers, what is 99 divided by 100? 0.99, and you convert that to an int, and what do you get? 0. All right. So to be clear, I won't be using integer division when I calculate your grades, because you'd either get 100 or you'd get a 0, But anyway, so the problem here, 22 is an int, 7 is an int. So to fix this, I have several options. Now, here's a question. Well, we'll just do this. Here you go. This is now a floating point constant. So this is a floating point constant divided by an int constant. So we call that mixed mode arithmetic. I'll probably remember and talk about that again in our next lesson. But anyway, if you have 2 ints, the result is going to be an int. 2 floating point numbers, the result is a floating point number. What if it's mixed? Well, then it's going to be the one that is deemed more accurate, if you will. So if you divide a floating point number by an int, the quotient will be calculated and returned as a floating point. So putting a 0.0 there, that would fix it. Just one or the other. Then it becomes that mixed mode. We're going to do the floating point. So that would fix it. That would fix it. And again, we could do this also. That would typecast. Now, to be clear, what are we typecasting? The thing to the right. What is it that's to the right? Is it the 22 or is it the quotient 22/7? Just to see if you remember that. So like now to be clear, because of the parentheses, what's to the right of the typecast is the quotient. What's the quotient? 3. The quotient is 3 because these are both ints, right? The quotient is 3, and when you typecast the quotient, it's going to turn the 3 into a 3.0. Okay, so we'll verify that real quick. We will cat and compile and Run. Yeah, so anyway, the quotient is 3, and then we typecast it as a double, and what gets assigned to pi? 3.0. That really didn't help. So back in we go. So the other thing to do would just be get rid of the parentheses, and again, you remember my goofy definition on typecast, the thing to the right. It might be the result of an expression, that's what we had earlier. Now the thing to the right is the 22. So now we're dividing a floating point 22 divided by a 7. So this is just an alternative now to putting a 0.0 after one or the other of those constants. So this will fix it too. So this will get us the more accurate version of pi, but it's still not the best version of pi. The one I had memorized all these years ago was even better. So, hey, this is more digits, so it's even more accurate. Oh, whoa, 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 until you look at it more closely. 3.14, we strike out at the third digit. All right. So it's an improvement over 3, but still that's not best. So back to the code we go. Back we go. I think we're done with this. So anyway, so Java does recognize that sometimes you want to have a variable that doesn't vary. It doesn't vary. You know, why did I even bother to put this quantity 3.14 yada 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 into a variable? I could have just put 3.1415 yada 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 here and here and here. Okay. Oh, let's go to our notes. Pro tip. We generally want to avoid having the same constant appear multiple times in our programs. You know, the fix is to use a, oh, here we go, I'm tipping my cards, a quote, final variable. We'll get to this in just a second. We'll let you type it in your notes, and we'll go back and fix our code and take our own advice. All right. How are we doing on time? Just fine. Alrighty. Got a little more typing and scribbling going on still. Trying to make that a little bigger. Let's do this. And, you know, I don't know, is that, how's that? Okay, back down we go. Is that better there? Okay. Even at that, looks like a kind of small font. But I appreciate you guys being here today. Was anybody do a Google to find out, are we closed today? Is campus closed for President's Day? You know, because I think the ISDs are closed if I remember correctly on President's Day. Yeah, okay, thanks, Bruce. But nope, we're dragging you up here then, even on Washington's birthday, President's Day. Okay, so we want to avoid having the same constant appear multiple times, because I mean you can well imagine, you know, gosh, especially as I've gotten older, I'm still pretty fast at editing because I know all the shortcuts, but I'm not a very accurate typist. I make lots of typos and so on. And so you can imagine if I right here had to type in 3.141592654, and then I came down here and I typed in the same quantity. I came down here, typed in the same quantity. One of those would be wrong, and you wouldn't notice. You wouldn't notice. So this pro tip isn't, it's for a reason, and you might make mistakes or something. And the other thing is, later on you come back and you say, hey, we've used our supercomputer and we've generated more digits of pi. We want to go back and update our program. Well, if I had typed in the constant 3.14 yada 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 15 different places in my program, then I have to go make 15 changes, and I might skip one somehow. Okay, so we see it's a code maintenance issue, it's a code accuracy, if you will, issue, and so on. So with a little luck, I could type it in once and get it right. Okay, I want to type it in once and get it right. So I'm going to assign it to a variable, but we don't want this to happen. Someone just clobbered our more accurate version of pi. They were, they had their heart in the right place, but they were incorrect in thinking that this was more accurate. There's more digits, but it's actually less accurate. We don't want some new programmer coming along here and reassigning pi, in their little piece of the code they're responsible for or whatever. So we want to prevent that. How do you prevent it? Again, I tipped my cards back here in our notes. We're going to fix that by using a, quote, final variable. So a final variable, you just put the word final in front of our variable declaration. Final is a reserved word in Java. It would be in that list of 50 reserved words. And final will specify, you specify that the only place that has any application at all is on a variable declaration statement where you also initialize the variable that you're declaring. You know, we're declaring pi to be a double, and we're giving it an initial value here. Anyway, you can put the word final on that variable declaration statement, and that tells Java, hey, I don't want this variable to get clobbered. I don't want anybody else later on coming along and messing up that variable. So by putting final on it, it's not going to allow this, where I'm trying to reassign pi. The only change I've made to the program is putting the word final here. Let's see what it does now when I try to reassign pi. So we will cat, for good luck, we're going to need it, compile, or we'll try to compile. Cannot assign a value to a final variable. The final variable pi here, on line 21, we are trying to reassign our final variable pi. The compiler won't allow that. So back in we go. Oops. So what the heck, I'll leave that here just as a point of discussion, if you will. In fact, I guess I also don't need the print statement for pi since we're not being allowed to change it. So by declaring variable pi to be a final, we give it the initial value. This is our one shot to get it right. We double check it there. We use it throughout the program. So this, again, this is the solution. We only had to type it incorrect once. We used it multiple times. We don't have the same variable appearing multiple times, which our pro tip said to try to avoid. And also, by making it a final variable, we prohibit some silly person coming along later and clobbering this variable, trying to reassign it something different. So it's a great little solution. So we'll just make sure this works, and we'll call this good here on this example. Then we'll talk about lab 2 and send you guys packing. So we will cat and compile. And eventually run. Hey, there we go. So now we're getting a more accurate version of our area then for our last one, instead of using 22/7 or even worse, just 3. Looks pretty good. Questions on vid8e? All right. So as a result of this, we're going to say that you guys are now experts in using some. Now we made it kind of easy here, I guess, for ourselves in terms of estimating the answers and so on. We're using just integer radiuses, radii. All right, we're using integers for the radius of our circles that we're calculating the surface area of. But we're getting pretty good at that. But still, the problem with this program is it calculates the area of a circle for a circle with radius 3, a circle for radius 4, and a circle for radius 5. How could we improve upon this program? Instead of having it just calculate the area of a circle with those 3 radii, how could we make the program more, hint, hint, flexible? Interactive. Ding, ding, ding. Very good. All right. So what we're going to do then, my dear friends, we're going to take the logic that we've added in today with this sequence of programs and so on that lead us up to this. We're going to take that plus your lab 1 and marry those together. Lab 1 was interactive, and it prompted you, not for the radius of a circle, it prompted you for a number or for a grade. And then it calculated the sum and the count, and ultimately then divided the sum by the count to calculate the average and so on. But it was interactive, was a good starting point there. Just like, well, our vid8.java was interactive, and our video vid8d was also interactive. You could use one of those if you want, whichever. But so we're going to kind of, again, marry lab 1 and this program right here. So what we want lab 2 to do is prompt the user to enter the radius of a circle, and we'll tell them the exact same thing. When you're done, enter -1. We're not going to calculate the area of a circle whose radius was -1. So when they enter -1, we're going to abort. Also, just like lab 1, and unlike anything we've done here today, so I'm leaving that up to you guys to, again, kind of connect the dots, lab 2 will execute in a loop, as did lab 1. So you'll prompt the user, enter a radius. They type it in, you read it in, convert it to an int, do your little calculations, print out the area, come back, prompt them again. You read it in, convert it to an int, do your calculations, print out the answer, loop back again, read it in, until the user enters a -1, just like lab 1. There's another little twist, which we'll talk about in just a sec. Let me open up permissions, and we'll look at the assignment on the web. All right, so cd to pub, PF1. We'll bring it up on the web here. All right, and I'll type that into our assignment then. All right, so lab 2. So just for the heck of it, let me real quick here do this and this, and we'll make this official here. I'll probably state the due date after we stop the video, but anyway. So homework is going to be, all right, and let me paste it just as regular old text here. I think that's that one. Yeah, there we are. So do make a note of the URL. All right, I thought there was a question there, Talton, but just a stretch. All right. So let's go back to the assignment. All right, so we have reviewed variable declarations, assignment statements, yada, yada, yada. At the end, we developed a simple program that would calculate the area of a circle whose radius was hard-coded. That's the term that we should use right here. Oops, not the wrong one. Let's come over here. So in this case, we hard-coded the radius to be a 4, and then we hard-coded, and it's not flexible, we just assigned it some constant. So that's the term that would be appropriate for a programmer to use. Take that program in your lab 1, combine them together into a single program that is an interactive area calculator. Prompt the user for the radius, which we're going to assume is an integer. All right. Calculate, display the area, and repeat until a -1 is entered. Do note here, now once again, this should be starting to be a habit. So your lab 2 will be in a file called lab2.java. Note the capital L. Why the capital L? Because it's connected to the class name, and we have a rule that says class name should start with a capital letter. PF1, of course, is uppercase. Lab 2 is lowercase. So it's just like Lab 1. Your Lab 2 directory will be a sibling of Lab 1. But do double check to make sure that you get it in the right spot with the right name and everything else then. And oh yes, remove any extra code from Lab 1 that's not needed. I don't want to see any variables there for count and sum and average and, the extraneous comments from Lab 1 and so on. In fact, as far as I'm concerned, you could do like we did when we copied Lab 1 and used it for 2 sample programs today. I got rid of all of those comments. For simple little programs that are a half a page, you really don't need to, there's not much need to comment such a simple little program. We did in Lab 1 because you were brand new to it, but now you're old hands at it, I guess, so we can skip the comments. So get rid of all the extra junk and use better variable names. I don't want sum or average or count to be in your program at all. How about R or RAD or something like that, and AVG and so on. Use good descriptive variables. And then, oh yes, one more thing. Again, I like to just ask you guys to kind of take the ball and take it one other step on your own. So in addition to marrying these 2 programs together, your Lab 1 and this thing here, in addition to that, also, after you've written the code to calculate the area of a circle, add more code to calculate the volume of a sphere with the same radius. So if you don't have it memorized, you might just do a quick Google. What's that formula to calculate the volume of a sphere with radius r? And it'll spit it out there for you then. And you'll need to do something with that then also. Okay. And I'll tell you, I'll mention it now. With a little luck, I'll remember and mention it in the next lesson also. Part of the formula for the volume of a sphere has a quotient involved. So, oh yeah. And so when you're dealing with the quotient of 2 integers, and when you Google and find the formula for the volume of a sphere, it's going to have this quotient of 2 integers. But note, you don't want to do integer division on that quotient. Just like right here, we don't want to do integer division. So make a note to remember, when you convert that formula you find online, you need to tweak it just a little bit to make sure that you do floating point division, not integer division. Okay? So make a note of that. Because if you don't, what could happen is you write your program, it'll spit out a result, you look at it, okay, I guess that makes sense, it's a computer, it's a program, it's got to work right, but you actually get a wrong result. And if you didn't go to the trouble of pulling out a calculator or something else like that, then you might not note that your answers are not as accurate as they need to be. Okay, so do watch that. So what's left? We're going to come back then next lesson, and we're going to talk in greater detail about operators. We've really kind of laid the groundwork quite a bit, so we'll be able to blaze through that without any trouble then. And with a little luck, we'll stop early then the next class period to give you time for Q&A if you have it on your lab after you've hopefully got started on it. That'd be very good if you can start then ask questions here in person when we meet the next class period. And that'll be it. I'm going to stop the video. Any questions on the lab, the examples, anything else like that? All right, you guys. I'm going to stop the video then. We'll pick a due date, and I'll then also post that due date on Blackboard then also when I post this video. All right, that's it for now.